Disconnecting grounding rods from separate off-grid and on-grid systems can create a ground loop. This ground loop can cause voltage differences and potential safety hazards. A generator panel should switch both hot wires and the neutral to prevent voltage imbalances. Bonding a panel to a water pipe may not provide an adequate ground path, especially if the water pipe is plastic or not properly grounded. Voltage problems could be caused by ground faults. The electrician's actions may have created ground faults, which can cause voltage drops or surges. Circuit overloading can also be a cause if the combined load from both systems exceeds the capacity of the 200 amp subpanel. Voltage problems can occur. A transfer switch that does not switch the neutral can cause voltage imbalances, resulting in voltage problems. It is unclear why an electrician deviated from the approved plans. However, the following reasons are possible. Firstly, the electrician may not have been fully qualified to handle the complex electrical work required. Secondly, the electrician may have tried to cut costs by using cheaper materials or taking shortcuts. Thirdly, there may have been a miscommunication between the electrician and the inspector or utility engineers. Recommendations include: firstly, engage a licensed and experienced electrician to inspect and correct the electrical system. Secondly, install a generator transfer switch that switches both hot wires and the neutral. Thirdly, evaluate the grounding system and ensure that it meets code requirements and provides a safe and effective ground path. Finally, consider an isolation transformer, as an isolation transformer can help isolate the two electrical systems and prevent potential voltage problems. Proper grounding is critical for electrical safety. According to the National Electrical Code, or NEC, a grounding electrode system typically consists of a ground rod, ground ring, or metal underground water pipe. The purpose is to provide a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers. Ground loops occur when there are multiple paths for ground current to flow. This can happen when multiple grounding electrodes are interconnected, creating a loop. The circulating current in the loop can cause voltage drops and interference. Neutral to ground bonding is essential for safety, but it must be done correctly. In a typical service panel, the neutral conductor is bonded to the ground. However, this bonding should only occur at the service entrance. Bonding the neutral to ground at multiple locations can create parallel paths for neutral current, leading to ground loops and potential shock hazards. When using a generator, a transfer switch is necessary to isolate the generator from the utility power. A properly designed transfer switch will switch all conductors, including the neutral. This prevents the generator neutral from being connected to the utility neutral, which can create a ground loop. Water pipe bonding is often used as part of the grounding electrode system. However, it's important to ensure that the water pipe is metallic and makes good electrical contact with the earth. Plastic water pipes do not provide a reliable ground path. Ground faults occur when current flows through an unintended path to ground. This can happen if insulation fails or if there's accidental contact between a live conductor and a grounded object. Ground faults can cause voltage drops, equipment damage, and shock hazards. Circuit overloading occurs when the current draw exceeds the capacity of the circuit. This can cause voltage drops and overheating, potentially leading to fires. It's important to ensure that circuits are not overloaded and that overcurrent protective devices are properly sized. An electrician's deviation from approved plans can have serious consequences. It's essential that electrical work is performed according to code and that any changes are approved by the relevant authorities. Using unqualified electricians or cutting corners can compromise safety and reliability. When hiring an electrician, it's important to verify their credentials and experience. A licensed and experienced electrician will be familiar with the NEC and will be able to perform the work safely and correctly. The NEC provides detailed requirements for grounding and bonding. Article 250 covers grounding and bonding requirements. It specifies the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods for bonding different parts of the electrical system together. A generator transfer switch should be installed according to the manufacturer's instructions and the NEC. It's important to ensure that the transfer switch is properly sized for the load and that it switches all conductors, including the neutral. When evaluating a grounding system, it's important to consider the size and type of grounding electrodes, the size of grounding conductors, and the connections between different parts of the system. A properly designed grounding system will provide a low impedance path for fault current and will help to protect against shock hazards. An isolation transformer can be used to isolate two electrical systems from each other. This can be useful in situations where there are concerns about ground loops or voltage differences. Isolation transformers provide electrical isolation and can help to improve safety and reliability. The cost of electrical work can vary depending on the complexity of the job and the materials used. It's important to get multiple quotes from different electricians and to compare the prices and the scope of work. Cutting corners on electrical work can be dangerous and can lead to costly repairs down the road. Proper grounding and bonding are essential for electrical safety. It's important to ensure that electrical work is performed according to code and that the grounding system is properly designed and installed. Regular inspections and maintenance can help to identify and correct any problems before they become serious. In a grid-tied system, the neutral is grounded at the service entrance. This provides a return path for current and helps to protect against shock hazards. In an off-grid system, the neutral may not be grounded. This can create a floating neutral, which can cause voltage fluctuations and equipment damage. It's important to consult with a qualified electrician to determine the best grounding strategy for an off-grid system. When connecting an off-grid system to a grid-tied system, it's important to ensure that the two systems are properly isolated from each other. This can be done using a transfer switch or an isolation transformer. Connecting the two systems together without proper isolation can create ground loops and other problems. The NEC requires that all electrical equipment be properly grounded. This includes appliances, lighting fixtures, and other electrical devices. Grounding helps to protect against shock hazards and can also improve the performance of electrical equipment. Grounding conductors must be properly sized and installed. The size of the grounding conductor depends on the size of the circuit. Grounding conductors must be securely connected to the grounding electrode and to the equipment being grounded. Bonding is the process of connecting different parts of the electrical system together to create a low impedance path for fault current. Bonding is important for safety and can also improve the performance of electrical equipment. Bonding conductors must be properly sized and installed. The size of the bonding conductor depends on the size of the circuit. Bonding conductors must be securely connected to the different parts of the electrical system being bonded together. The grounding electrode system should be inspected regularly to ensure that it is in good condition. Ground rods should be driven deep enough into the ground to ensure good contact with the earth. Ground rings should be buried at least 30 inches below the surface of the earth. Metal underground water pipe should be bonded to the grounding electrode system. The connections between the grounding electrode and the grounding conductors should be checked regularly to ensure that they are tight and corrosion-free. If any problems are found with the grounding electrode system, they should be corrected immediately. Fault current is the current that flows through an unintended path to ground. Fault current can be caused by insulation failure, accidental contact between a live conductor and a grounded object, or other problems. Fault current can be dangerous and can cause shock hazards, equipment damage, and fires. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect against fault current. These devices will trip or blow when they detect a fault current, interrupting the flow of current and preventing damage. The NEC specifies the types of overcurrent protective devices that are permitted in different applications. It's important to use the correct type of overcurrent protective device and to ensure that it is properly sized for the circuit. Arc fault circuit interrupters, or ARCs, are a type of overcurrent protective device that is designed to protect against arc faults. Arc faults are a type of electrical fault that can cause fires. ARCs are required in many areas of the home, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are a type of overcurrent protective device that is designed to protect against ground faults. GFCIs are required in many areas of the home, such as bathrooms, kitchens, and outdoor areas. Surge protective devices, or SPDs, are designed to protect against voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other problems. SPD can help to protect sensitive electronic equipment from damage. Electrical safety is everyone's responsibility. It's important to be aware of the hazards of electricity and to take precautions to prevent accidents. Never work on electrical equipment unless you are qualified to do so. Always turn off the power before working on electrical equipment. Use the correct tools and equipment for the job. Follow all safety precautions. If you are not sure how to do something, ask for help from a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can help to protect yourself and others from electrical hazards. Remember, when in doubt, consult with a qualified electrician. They can help you to ensure that your electrical system is safe and up to code. In the specific scenario described, the presence of both off-grid and on-grid systems introduces complexities in grounding and bonding. The multiple ground rods and the ground ring, while seemingly providing enhanced grounding, may inadvertently create ground loops. The connection to the water pipe adds another layer of complexity, particularly if the piping system incorporates non-conductive sections. The key takeaway is that a holistic assessment of the entire grounding and bonding infrastructure is paramount. A qualified electrician with expertise in both off-grid and non-grid systems should meticulously evaluate the existing setup, verify compliance with the NEC, and implement necessary corrective measures to eliminate ground loops and ensure a safe and reliable electrical system. The deviation from approved plans raises concerns about potential code violations and safety hazards. It is imperative to address these discrepancies promptly and ensure that all electrical work adheres to the original design and meets the requirements of the local electrical inspector and utility engineers. Ignoring these issues could lead to serious consequences, including electrical fires, equipment damage, and potential harm to occupants. To reiterate, engaging a competent electrician is the most prudent course of action. Their expertise will be invaluable in resolving the existing problems and preventing future ones. The cost of hiring a qualified professional is a worthwhile investment in ensuring the safety and integrity of the electrical system. The NEC in section 250.50 discusses the requirements for grounding electrode systems. This section emphasizes the importance of creating a low impedance path to ground to facilitate the clearing of ground faults. The code also specifies the types of grounding electrodes that are permitted, such as ground rods, ground rings, and metal underground water pipes. Section 250.52 provides further details and the specific requirements for each type of grounding electrode. For example, ground rods must be at least 8 feet long and must be driven into the ground to a depth of at least 8 feet. Ground rings must be buried at least 30 inches below the surface of the earth and must encircle the building or structure. Metal underground water pipes must be in direct contact with the earth for at least 10 feet. In addition to the grounding electrode system, the NEC also requires that all metal enclosures and equipment be bonded together. This is to ensure that there is a low impedance path for fault current to flow back to the source. Bonding is typically accomplished using bonding jumpers, which are conductors that connect the metal enclosures and equipment together. The size of the bonding jumpers depends on the size of the circuit. Section 250.102 provides guidance on the sizing of bonding jumpers. The NEC also addresses the issue of ground loops. Section 250.6 prohibits the use of multiple grounding electrodes in certain situations, as this can create ground loops. Ground loops can cause unwanted current to flow through the grounding system, which can lead to voltage drops, interference, and other problems. To avoid ground loops, it is important to use a single-point grounding system. In a single-point grounding system, all of the grounding conductors are connected to a single grounding electrode. This eliminates the possibility of multiple paths for ground current to flow. The NEC also addresses the requirements for generator installations. Section 702 provides guidance on the installation of emergency and standby power systems. This section requires that generators be equipped with a transfer switch to isolate the generator from the utility power. The transfer switch must be designed to switch all conductors, including the neutral. This is to prevent the generator neutral from being connected to the utility neutral, which can create a ground loop. In addition to the NEC, there may also be local codes and regulations that apply to electrical installations. It is important to check with the local electrical inspector to determine the specific requirements in your area.